So we've cut all the corners in the engine design. Manufacturing is last minute. The engine is being assembled and started for the first time 1 week before the race. I mean, what could possibly go wrong? So, quick recap for you guys. We're manufacturing the parts in the order that they're basically needed for They managed to get the whole engine together, and that was about, I think, 2 weeks, 1.5 weeks before the World Time Attack race, something like that, I think. So they have the engine together. Fire it up, starts first try, so really nice. Of course, I mean, you can start up a potato on the first try, so that doesn't necessarily mean that the engine is good or bad or anything like that. But it's, of course, I mean, a good sign that, okay, like, you have compression ratio, you have the correct fuel amount, and you have some ignition timing, and the camshaft timing is sort of more or less in the ballpark. So, I mean, these are, of course, more or less all attributes to the guy assembling the engine and the ECU guy for tuning it. But, I mean, yeah, still always good. So they have the Thor engine started up. So working great, sounding great, no vibrations, or, I mean, of course, there are some vibrations, but it's like even less vibrations than a factory Porsche engine that comes with balance shafts, and our race engine does not have balance shafts, of course. So really positive news from that. And yeah, so next up was starting to dyno it. I mean, of course, we're still in Finland, so I'm more or less sort of guessing and based on my knowledge of what they were doing over there in Australia. But yeah, so yeah, put it on the dyno over at PR Tech and started to ramp up the RPM and the sort of power levels, and things are looking really good. Doing good horsepower, normal aspirated, building boost very early. So I believe the ECU guy said that they were even having problems sort of mapping the part throttle area, because even at part throttle they were getting almost full boost already at 4,000 RPM or something like that. So really sort of kind of good problems to have, but still problems nonetheless. But yeah, then they did encounter actual problem. So they had sort of based on their knowledge over years of doing race engines and Porsche engines, that okay, we want a sort of certain amount of well, not boost pressure, but certain amount of oil pressure in relation to engine RPM. And so this is, of course, you need to have enough oil pressure to get the oil to all the sections of the engine where there needs to be oil. And so one of these main things is to get oil to the connecting rod big end bearing. So there, in a sort of conventional oiling drilling through the crankshaft, you need to have enough oil pressure to be able to force the oil into the center of the main bearing pin there. And then after that you sort of have a free exit to the or sort of free sort of centrifugal force assisted oil feed to the connecting rod big end bearing. And they knew pretty much, okay, we need this amount of oil pressure to do that. Of course, I mean, we had designed the crankshaft to be able to cope with a lower oil pressure, but they were not comfortable with that. They this is the sort of oil pressure we want to be able to achieve. So okay, I mean, no problem. So they geared the oil pump to spin that a little bit faster. And so in case you're not familiar with how dry-sump oil pumps work, I mean, they basically work the same as wet-sump pumps also, but they have separate. The things are basically separate, and there's like extra features. So with a dry-sump pump, you have scavenge stages that suck the oil out of the crankcase and engine components. So turbo oil return, which would be here, And yeah, the different crankcase sections of this is cylinder 1, cylinder 2 and 3, and cylinder 4 on a 4-cylinder engine. And yeah, so you suck out all the oil mist, and some air also from the crankcase. This is a larger oil pump that we have for our ER8. So we have a integrated hydraulic pump and a mechanical fuel pump also, because yeah, the power levels required from the fuel pump are so high that you will start taxing the electrical system. And yeah, that's a story for our ER8, the Tech series, but yeah, stay tuned for those. Anyway, so yeah, in between here we have a air oil separator, which when you yeah, scavenge out all of the oil and air and sort of oil mist into the pump, we have so not all dry sump pumps will have this separator, but we feel this is very, very important, especially for untested engines, to reduce the likelihood of having problems. So if you're not foaming your oil, you maybe be able to get away with not having an air oil separator. But if if you're not sure, or you do have foaming issues, then you need to have a mechanical air oil separator. So I mean, there's nothing mechanical like selecting this is an oil particle and this is an air particle, but you're using a centrifugal force, and with a sort of high energy state, then you can separate the liquids and gases by mass much more efficiently than sort of other like passive type separators, which if you have a very foamed oil, then those are not going to be able to separate the oil from the air anymore. But yeah, so from this air oil separator, we have a oil feed with very high quality oil. So oil doesn't refer to how high a quality the oil is, but how sort of the air amount in the oil feed outlet. So that is very high quality, and that goes into the tank. And we have the air fitting also to the top of the tank, basically to provide a pressurization equalization between the tank and the crankcase system. And then from the yeah, you have a separate tank, and then that tank has a oil return or oil exit, or whatever you want to call that, into the high pressure section of this pump. And that high pressure section, yeah, then feeds high pressure oil that will go into the engine through an oil filter, of course. And you also, of course, need to have oil cooler somewhere in the system, and depending on if that is air air oil cooler or air water cooler, and what kind of a construction and size that is, either needs to be in the pressurized section or in the non-pressurized section. And yeah, but yeah, so you have a high pressure oil then exiting the pressure section through some components into the actual bearings in the engine. So yeah, they gear the pump to run that at a higher RPM to get a higher mass flow through the high pressure section. And of course, I mean, that increases oil pressure, and they gear that higher to get more oil pressure. But then they ended up, so when you're looking at the oil pressure plot, basically, you end up sort of maximizing the oil pressure, and then you start having these sort of dips and stuff in the oil pressure sensor, or in the oil pressure sensor feed. So that is, yeah, one of the reasons why it's very important to not filter your sensor signals. I mean, you see so much of that, and oh no. But yeah, these guys are good, so they're not doing any of that crap, but actually looking at things to see if something's wrong. And yeah, they were yeah, running the pressure pump at such a high RPM with the inlet mass flow so high that they started cavitating the pump. And cavitating basically means that if you have a solid liquid feed, then you're lowering the pressure sort of locally, either through turbulence or pressure fluctuations or static pressure, that you have a sort of inconsistent vaporization of the liquid. So you have sort of oil vapor forming locally, and that creates sort of gas pockets in the oil feed into the engine. And of course, oil doesn't lubricate very well when it's in a gas form. You need to have it in a liquid form where it has a much higher mass flow, of course. And yeah, then you have some viscosity and stuff like this that is reasonably important for your bearings to survive. So you definitely don't want to be doing that. And yeah, gearing the pump down again, they weren't able to achieve the oil pressure that they wanted. So yeah, they had a problem there that they needed to solve. And yeah, stepping back a little bit from that situation. So I mean, yeah, now in hindsight, knowing the specifications and yeah, what we knew and what we could have known. So basically, the engine components were more or less specified for drag racing use, because these are, I mean, the power levels are just so much higher than what any sort of conventional circuit layout is, that we didn't really know what kind of bearing clearances and stuff like this we need in the engine. And yeah, so the clearances they use on drag racing are very high, because they run the components to the absolute braking limit for a very short period of time. So you have high flex in the crankshaft, the engine block is flexing, the connecting rods are moving around, and like everything is flexing and moving. And in that case, you need to have relatively large clearances in the bearings, so that when like a connecting rod pin flexes around and moves, and it's not in the correct angle anymore to the engine rotation, then that will start binding up the connecting rod big end, because that is again held in place by the pin, so it's not like free to rotate in absolutely every angle. So you need to have enough clearance there to prevent the corners of the bearings from binding up, because as soon as you bind up, then yeah, that just forces out all the oil, and you end up heating up the bearings, and you destroy the engine very, very quickly. So yeah, so the clearance specifications were very high, or very on the sort of loose side of things. And this was, yeah, one of the things that we said, okay, like we don't have 1 or 2 days or something like that to do really detailed calculations on what the oil clearances need to be. So run the recommended oil clearances for drag racing use, and we just need to run a pump big enough to be able to supply oil feed, if that oil feed happens to be like significantly higher than what we typically use. But the oil pump that they were using, so they were running a smaller version of this pump that is more than big enough for a normal 4-cylinder circuit racing engine. But circuit racing engines, so with those you have much longer run times on the engines, so the components can't flex around as much, and you can run much smaller bearing clearances. And also because you have longer runtime on the engine, you want to reduce the heat production amount as much as possible, both into cooling system and to the oiling system. And so a good way to reduce power into the oil system is to run as low power from the oil pump as possible. So you want to run smaller bearing clearances, so you need less mass flow in the oil system. So you need a less powerful pump, of course, to provide that lubrication then, and that means less heat is going into the oil system, and you need less cooling for the oil system, which benefits the aerodynamics of the car also, because you can run a smaller radiator, or less airflow through the radiator, or yeah, something like that. Or you can locate maybe the radiator in a better location, or yeah, there are multiple benefits to that. But in hindsight, so yeah, that was something that we didn't communicate very clear. I mean, we were absolutely fully tanked, so it was not something we forgot or something that we didn't do together with Rod and the PR Tech guys, but just simply one of the things that wasn't sort of on the sort of highest end of potential issues, which I mean in this case ended up being an issue. But yeah, this is when you're building a prototype very, very quickly and having someone else put that together, and you're not able to test things beforehand, some things can happen sometimes. And I still think that the engine probably would have ran with that lower oil pressure. But then again, yeah, I mean, Rod is the boss, and the PR Tech guys are the people actually servicing the thing and stuff like that. So of course, yeah, I mean, they're free to decide what they want to do with on the components they've purchased from us. But the end result of all of this oil pressure stuff, yeah, was that they had, what was it, 3-4 days, something like that, till the race. And they were like, okay, we need to do the decision now. Like, can we solve this oil pressure issue in time for the race or not? Or what are we going to do? So yeah, they ended up deciding to going back to their previous year's engine. So yeah, they swapped that back. They had all the engine mounts and stuff like that, of course. And I mean, yeah, we had the Thor engines, so the version they have on the RP968, all the bolt patterns for the bell housing and the flywheel and the crankshaft and all of that built to be compatible with their engine, so that they wouldn't, for their old engine, so that they wouldn't need to redo absolutely everything. And yeah, so they were able to just swap their old engine back in there, put that together, and get over to the race track and the event. So yeah, I mean, kind of a bummer to not have the Thor engine running at World Time Attack 2017. which we were really looking forward to. But on the plus side, I mean, they had started the engine, they had run it on the dyno, we had some figures for that, we had some information on the boost behavior, and we had some videos on that also, and still had a complete full engine that we could show at the event. So that was positive, at least. not all was lost. And that boost behavior. So you have some problems when you start going in the circuit racing stuff sort of above 1,000 horsepower, especially when you're going like 1,200 plus horsepower. Then you end up with problems with your turbochargers. Not that there aren't turbochargers available, but these the turbocharger components start getting really heavy, because they start getting big, and those are not typically used for circuit racing things anymore. So the solution they had on the RP968 was to run two smaller turbos, which you could get circuit racing variants of that were or circuit racing variants, but as sort of turbochargers suitable for circuit racing, so lightweight components, really. But the turbos they had were actually really small for our Thor engine. And I mean, this is again, I mean, not directly related to this, but sort of a general thing where you see a lot of problems selecting components for a different use and different engines, which is, sometimes huge problems. Because obviously, I mean, when you're talking to sales and marketing people on what kind of a turbo you need in this case, then it's so easy to have people that actually have no clue what they're talking about. Of course, engineers actually designing things, or the researchers, will most likely in all companies understand things, and they would be able to figure out, okay, this is what you need for this kind of a package. But if you're selecting a turbocharger size, and people start asking you okay, it's how many cylinders does your engine have? Then you're like, no, guys, doesn't work like that. So when you select the turbocharger to fit the engine, you need to select your compressor size, or the inlet size on your compressor wheel for the choke flow, so basically the maximum amount of power you need to make. Then you need to select a sort of a wheel size that will provide that power at the correct pressure ratio that you want to run, or that you're going to be making that power at on your specific engine that you're running. And then once you have the compressor side figured out, you need to check, okay, can we get a turbine size that actually works together with the engine on this? And the turbine size is basically, you choose that based on how much mass flow your engine is going to be doing normally aspirated. So that will say what kind of a RPM range you're going to be able to put out sort of enough mass flow to build up pressure ratio and get your turbine spinning. And if you select that too small, you're going to be building boost very early, but then you're going to have a very high back pressure, so the pressure in the exhaust manifold higher up in the RPM range. So you're going to be limited to a narrow RPM, or power band is going to be very narrow. So you're building boost early, but then you're not making holding the power to higher RPM, because your turbine size is so choked that you can't run that to higher RPM. And then again, if you're running a turbine that is much too big again, then you're going to be making boost very, very late in the RPM range, and you might end up with a 500 or 1000 RPM power band right before red line, and that is really horrible also. I mean, you could, in some racing you can get away with that, especially if you're able to run a very aggressive anti-lag system or launch control, like for drag racing, for instance, especially with automatic gearboxes or these direct shift clutchless upshift things. Then you can maybe get away with that. But for circuit racing, it needs to be selected perfectly. And even if you choose your turbo perfectly, so that's when you start ending up with problems for circuit racing. So when you end up we want to do 1500 horsepower, and we need a really big turbo, because for instance our Thor engine will push out about 500 horsepower naturally aspirated, and that's in turbocharged trim, so with camshafts and a compression ratio for turbocharged use. And yeah, that means you need to run a very, very large turbine section, because otherwise you're going to be strangling the engine at higher RPM with really large exhaust back pressure. And yeah, then you end up with sort of turbos in the size range. I mean, other manufacturers also, but Garrett, for instance, you end up with a 5533 size turbo that ends up with factory Garrett that ends up with the whole turbocharger weighing about 30 kilos, which is insane amount of weight. And yeah, you don't want that much sort of mass hanging off of your exhaust manifold and dragging the car outside in the corners and things like this, because yeah, it doesn't help if your engine works really well and you're going fast down the straights. If you're not really lightweight in the corners, then you're losing a lot of cornering speed because you have so much weight in the car. And this is of course with high-end race cars where you have huge amounts of downforce. Otherwise the mass is not that important. I mean, you guys know this. You've seen all our ER8 the Tech Series stuff, so you know this already. But yeah, nowadays, for instance, we have these super lightweight turbine housings. So this is for the GTX 5533 series turbo, and the factory turbine housing is 14.9 kilos, and this is 4.2 kilos, something like that, if I remember correctly. So this yeah, removes over 10 kilos of weight from that 30 kilos. You pull that down to 20 kilos, and that's still kind of heavy. But now you're sort of getting into the region where there really isn't any better solution, because you can run two smaller turbos, but those plus the extra ducting needed for that ends up weighing like 10 kilos per turbo, is plus the extra stuff needed is sort of, yeah, you're not really going to be able to beat that. So being able to run a single 20 kilo turbo at 1,500 plus horsepower, then you're starting to be sort of mass-wise very competitive. And yeah, so nowadays you can run this, but back in 2017 this wasn't available. So then you had problems, and yeah, you just needed to see basically what was available. So that's why they ended up with relatively small turbos. And yeah, but I mean, it was good to get confirmation of that, of course, always. But anyway, we headed over to the racetrack, to the World Time Attack 2017 event in City Motorsport Park. So super nice event. I mean, Ian had stepped that up from 2016 like another notch. So yeah, a lot of companies over there marketing their newest products, having some discount sales also to get people really excited to come over there. Absolutely, yeah, the whole place absolutely packed with cars. The parking spots were like, yeah, full on the parking hill and stuff like that. So really impressive event, and I was super happy to be there. We had a stand there with the complete engine which was supposed to be running in the RP968, which yeah, unfortunately wasn't. But I mean, yeah, we still had super positive event. Lots of media guys coming over, so HP Academy guys. We had Kyle engineers, so YouTube series stuff. Well, I'll link to those videos here. Yeah, Kyle is working over in F1 now, and is unfortunately not able to do more videos at the moment, at least. But yeah, I mean, super good contacts, and lots of other really interesting people, competitors, really high sort of level competition going on there. We also had multiple multiple guys come over. Like, yeah, they came over to World Time Attack just to see our engine. Like, yeah, they were so bummed that the engine wasn't in the car running, and oh, that was so sad. But yeah, I mean, they had to come over and see the engine in person. I mean, it's so huge. I mean, so hugely awesome, and everything that was just, I mean, so like mind-blowing seeing that kind of a fan base for the engine that still hadn't like performed at a single race, and people were still there. And yeah, it turned out to be a really nice event with some really nice racing. And in hindsight, with the racing stuff, it was actually a good thing that the Thor engine wasn't in the RP968, because yeah, even with their old engine, I think they bumped the power output by about 50 horsepower, something like that. I think they thought that was the sort of ultimate limit of what that factory engine is capable of, which, I mean, they know that engine very well. So yeah, they're sort of know where the absolute limit is. But I'm not sure if they had some vibration issue or just sort of a power issue, because they ended up breaking a coupling in the drive line between the drive shaft and the gearbox. So they have a front mid engine with a drive shaft and a gearbox and a differential at the rear of the car. And at the rear there was a coupling that they broke. I'm not exactly sure what part that was, but one of those. And that happened on Friday. They brought the whole car back to the shop, disassembled everything to be able to change that, got that back on Saturday, ran that again, and ended up breaking it again. I think they got one lap or something on Saturday with that whole rebuild, but it was definitely worth it because they got P2 with that. That was an awesome effort by Rod Pobistek, the RP968 and the PR Tech team did a huge effort on that to be able to pull a second place out of that. But I mean, in hindsight, had they run the Thor engine, they might not necessarily even have been able to run a single lap, because they would maybe have broken the drivetrain before they would have completed a whole lap. So yeah, that was really happy for the team that they actually got P2 out of that. But I mean, of course, yeah, kind of a bummer that the Thor engine wasn't running, but good also. So hugely impressed with the event. I mean, yeah, we got lots of really interesting contacts there also. So yeah, on the way back from the event, we started by heading over to Melbourne. We bumped into a guy that was potentially building a really high performance car that we were looking at maybe providing the Thor engine for him, and yeah, looked at what other options maybe there might be. And yeah, so I mean, even like with some potential, it's always good to make new contacts and stuff like that, which yeah, was actually really good, because yeah, on a little bit further way back, so had a few days off. We stopped over in Cambodia, Thailand on the way back. I mean, flights cost the same, so why not? And yeah, I mean, you need to take a few days off. Like, the year is like yay long, and then you're working, and then when you have like a really long trip somewhere, then you try to sneak in a few days of vacation there, and that's, I mean, helps so much to motivate all these long trips and stuff like that. So always good. And yeah, as a last stop, I stopped over in UAE there, spoke with a new contact also there for some potential collaboration on future stuff, for providing engines or engine components maybe to them. And yeah, we're actually in discussions with them now in 2020 here for some collaborations. So yeah, I mean, you never know what kind of things can come out of meeting people, discussing things, seeing what could be done in the future. So really positive about that. And I mean, yeah, we didn't get P1. We didn't get the Thor engine running around Sydney Motorsport Park at max power, but it wasn't a bad result, so we're kind of sort of okay happy. I mean, 2017, it kind of was a missed year in that respect, but I mean, we did make a huge amount of progress, get lots of really good contacts for Elmer Racing, got our first complete designed engine that we did, started up first time. We had run on the engine dyno, lots of media interviews, so definitely not completely wasted, but maybe not all of the potential. But overall, I mean, a really positive year anyway. In next episode, we're going all in at World Time Attack 2018. Are we finally going to see the Thor engine running at Sydney Motorsport Park at World Time Attack event? Are we maybe even going to be competing for the win? Stay tuned and figure that out, guys. And yeah, that episode is coming out 19/6/2020, so 19th June. And yeah, you might want to stay tuned for that one, guys. It's going to be interesting. But yeah, this was it for today. So I'm Oscar from Elmer Racing. This was episode 3 of our Thor the Story. The year that was, or the race that was, but wasn't.